In this last video on the derivatives of trig functions, I just wanted to show two examples of things, interesting problems that might show up in the AP exam. Maybe not this first one, but then the one on the next page would. And but this first one is just meant to convince you that sometimes you want to do algebra before you go right to your derivative rules, because there might be an easier way to do it by using algebra. So let's find f prime if this is our derivative. Since I got a product here, sine times cosecant, I'm going to use the product rule, which says I'm going to take sine of x times the derivative of cosecant, which we just learned was negative cosecant cotangent. And then according to the product rule, I'm going to have to add that to the derivative of sine, which is cosine, times cosecant. So that seems like a long mess, but here's where you might want to use some of your trig identities. I'm going to turn everything into sines and cosines. Cosecant is negative 1 over sine. Cotangent is cosine over sine. And cosecant is 1 over sine. And now I can distribute this, and I get that just makes that a negative 1, so it looks like I get negative cosecant or cosine of x sine of x, or divided by sine of x, plus cosine of x sine of x, but those are opposites, so I get 0. So it's kind of a lot of work there if you think about it. We had to do the product rule, we had to use trig identities, and we ended up getting 0. The reason I did this is because you might notice that if I instead did a little bit of simplification before I took the derivative, I could have written this as sine of x times 1 over sine of x. And since those are reciprocals, I just get 1. So f of x is really just equal to 1. It's not actually technically equal to 1 everywhere. It's not equal to 1 at certain x values, because cosecant has asymptotes at 0 and pi, etc. But it's equal to 1 on its domain, and therefore the derivative of the constant 1 would just be 0. So you might have noticed that that the derivative was 0 more quickly if you had just simplified first. So that's sort of the lesson to take away from this example. And this example is asking us to evaluate this limit. And the reason I put this in here is because it's very common on the AP exam for students to be presented with questions like this. And they seem confusing because it doesn't seem like there's much you can do. What you need to notice is that this is actually just asking for a derivative. If the h's there should kind of give it away. Remember that the definition of the derivative is this. And it looks like we don't have an x in here, but we have an actual value of pi over 4. So this is actually saying, what's the derivative of pi over 4 for a certain function? And once you get here, we're kind of starting to fill in the details. Once you get here, you might say, okay, well, I know the point at which I'm taking the derivative. What is the function that I'm taking the derivative of? What is f of x? Well, it should be pretty obvious that it's tangent. So we're taking the derivative of tangent at pi over 4. And just to kind of, you should note that if f of x is tangent, the tangent of pi over 4 is actually 1. Right? Tangent of pi over 4 does give me this 1 here. So the point is that this limit is just asking us to evaluate f prime of pi over 4 if f of x equals tangent of x. So to do that, we would just say, well, if f of x is tangent of x, its derivative, as we just learned, is secant squared. And so f prime of pi over 4 is secant squared of pi over 4. And the secant of pi over 4 is 1 over the cosine of pi over 4. And the cosine of pi over 4 is 1 over root 2. So this is going to be root 2. But since it's squared, it's root 2 squared. So this is just 2. So the point of this problem is that we did not actually evaluate the limit by doing any algebra. We recognized the structure underlying this limit as the definition of the derivative of tangent at x equals pi over 4, and then we used our knowledge of that derivative and our knowledge of trig to get the answer. So for those taking the AP exam, be on the lookout for those type of problems.